Alright, so today's video is on section 6.1. And it's all about finding the area between a couple of curves. And you didn't know this, but you've already done it. In fact, you have, because when you're doing this equation right here, the integral of y equals x squared from 0 to 4 dx, what you were actually finding is this area in here, yes? What you didn't know was you're actually finding it between the equation y equals x squared, that's the upper function, and y equals 0, which was the lower function. Now, we don't normally show it like this, but we would have done just like this to do that equation. That is all there is to finding the area between two curves. Literally. The kids at the high school always say that. I like to say that too. Literally, that's all there is. So, for instance, here's our good friend y equals x squared. Here's our good buddy, I don't know, what is this, x plus 1 or something? Y equals x plus 1. And, yeah, this is y equals x squared. If I want to find the area between these guys, it's this area in here. Well, what I'm going to do is I'm going to take, and I like to write this way, the top function minus the bottom function. Or if you prefer, ceiling minus floor. Got my eyes in the wrong spot, or I missed an eye, I guess. Ceiling minus floor. That's kind of how I like to write it. Whichever way you want to write it. Dx, and then you're going to go from, wall to wall, where they intersect. Or unless you're told otherwise. And so that's how I do it. Ceiling minus floor from wall to wall. That's how I like to think about it. Okay, so I need to find, in this case, these two intersection points. Okay, let me pause while I pull up my calculator here. And we're back. So x squared, nice. X plus 1. Cool, and you'll notice that they intersect here and here. 0.618 and 1.618. So in this case, it's going to be the integral of top function minus bottom function from, what in the devil is going on? Negative 0.618, 1.618. And so, really all you'd have to do, of course, is just do your regular old antiderivatives from here to here. And you're done. Okay, I'm going to pull up my other calculator real quick. Should have grabbed them both while I was at it. Oh, virtual TI. There we go. Cool. So, on this thing, this is kind of the reason another reason I really like the TI calculator. I'm just going to go x squared divided by 2. Of course, you can do this with the Inspire as well. You can't do what I'm doing right here with the TI-84, but of course there are other ways to go about this. If you go such that x equals 1.618, you get helps you actually hit something right, Jay. It's such that x equals, apparently didn't type, there we go. And then do it again and come in here and get rid of that 1 and put in negative. Boom. And so then remember, it's just the top one minus the bottom one. And the answer is 1.863. Okay. If you come over and look at the graph, does that seem reasonable? Does this area between the two curves in there, does it look like it adds up to be like 1.5 squares? Then I'd buy that for a nickel, sure. Sure. Let's set up another one here. Okay? If you add, I don't know, x squared minus, I don't know, sine x, because we can. Let's do 5 sine x. And let's do, ooh, say, that's pretty. Let's make this a 0.5 just for, ooh, hey, that's nice. And then let's do cosine, maybe, of x. Oh, that's hot. Okay, cool. Now, suppose I want to find this actual area where they actually intersect. So from right there to right here. Okay, I could find that region. And in finding that region, I'd want to take the orange one, because it's on top, minus the other one. So in this case, it would be the cosine of x minus the other function. And I, for the life of me, don't remember what the other function was, so bear with me. 0.5x squared minus 5 sine x. Okay, now be careful. This is a classic screw up people forget to do. They forget to subtract the entire function. Been there, done that so many times it's embarrassing, to be quite honest with you. Alright, now remember whether they cross at here, negative 1.94, negative 0.194, and 2.634. 2.634. There we go. So it's going to be the cosine of x minus 0.5x squared plus 5 sine x. Just going to rewrite it there, if you don't mind. Alright, so where did sine come from, or cosine came from? It came from sine. So this is 0.5x cubed over 3. And positive sine came from negative cosine. That is who he is the derivative of. And 0.194 negative, 2.634 positive. Bring out your calculator. Make sure you are in radians whenever you're doing integrals and derivatives. So sine x minus 0.5x to the third divided by 3 minus 5 cosine x such that x equals and negative 0.194. Cool. And so it's going to be this fella minus this one. See, about 6.9, almost 7 units in there. Well, if you count this 1, 2, 3, 4, 5, I could convince myself that that's most of 7 squares inside of there. I could convince myself pretty well of that. Now note, they do not have to intersect to play this game. For instance, you might ask yourself, or somebody may ask you, Jay, between negative 5 and negative 1, how much area is between those two functions? So one of them, again, was cosine of x, and one of them was y equals 0.5x squared minus 5 sine x. Is it minus 5 sine? I think so. Isn't that right? Yes. Yes, sirree, Bob. Yes. Yes, I'd buy that. Oh. Right. Yeah. Good for me. Good for me. It's freaking me out just a minute. There. Now, note, on the interval from negative 5 to negative 1, who's on top of whom? Well, on that interval, the green is on top of the orange. So you got to subtract it the right way when you do the integrals. So it's going to be the integral 0.5x squared minus 5 sine x minus cosine of x from here to here. So of course this piece, I mean the answers that you got will be in essence the same. This was negative, positive on the previous problem, so this came from positive cosine this time. I don't think that surprises anybody. Those two flip-flop signs, so this one. And then minus sine x is where that guy came from. Okay? And then again, you know, this is the cool thing about this too. If you, I could come up here and grab this thing if I felt lazy. I think I kind of do feel lazy. So I'm just going to go in here and just going to alter these signs, right? I mean, that's just all what happened was they were just altered. Such that x equals negative 1 and negative 5. And then just grab this one minus this one. 23.75. In other words, there's quite a bit of area in there. And yeah, I bet you can see that there is. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yeah, I'd buy that for a nickel. That looks about right to me. So yeah, I could see where that would be about the correct answer. Again, I think that's what's kind of neat about graphing. The person can check themselves quite easily and be happy about it. Now, once in a while, I mean, most of our lives we're going to spend time talking about y being a function of x. But every now and again, you're going to need the x as some function of y instead. And so, for instance, this is the function x equals y squared. You're like, oh, it's like square root. Kind of. Notice how it's not truly a function, is it? Okay? It's not truly a function. We write it in that function notation. We say x is a function of y. And if you revamp, it is and it isn't. So it's not by our definition a function. But in this case, each y has one and only one x. How about that? Okay. So if you say it like that, then it does match the equation or the definition of function that we've kind of become used to. Okay, there's this one here, and then there's maybe this one here. Let's see here. Let's do, that is a straight line. I swear to you. And I have not been drinking. Okay, so let's try that again. Whee! Okay, cool. So this is the line y equals 5 minus x. Okay, that's great. How would I find this region in here? Well, very carefully. That's how I'm going to do it. If the function was turned on its head, where this was the top, this would be really easy to do, wouldn't it? I don't know if you can kind of see that in my video. When I turned it, it kind of went with me for a second, but maybe. If this were the top and this is the bottom, you would know what to do. Okay? But here's the thing. When they are functions of y, what we're going to do is this. We are going to take it from this. It's going to be, again, these are for functions of y. It is going to be right minus left from top or from bottom to top. Okay, in essence, it's exactly the same thing. Here you've got right, left, bottom, top. Okay, not very difficult to do. It's just going to remember if it's a function of y, it's going to be looking like this. So my function of y, this is not a function of y. I need to convert it. It is going to be now a function of y. So it's going to be 5 minus y minus y squared. Because the line is on the right hand side and the x and the y squared is on the left hand side. Notice this time it's going to be dy, which means that I'm not looking for x values of these points, I'm looking for their y values. Again, this is why I love Desmos so much. You can graph anything you like in Desmos in any way you like. Bam! You can't do that on a calculator, friends. X equals y squared. Bam! And we're interested in that point there and that point there. Notice we're talking about the y value, so that's negative 2.791. Negative 2.791. 1.791. Right? And so now it's simply a matter of integrating. So it's 5y minus y squared over 2 minus y cubed over 3 from here to here. Now, again, I like using this calculator for this. There is no, I mean, you're not impressing me if you can do it. Well, maybe you impress me a little bit, but you're not really impressing me that much if you can do this all in your head or you do it on your iPhone calculator or whatever. It's just plugging in numbers, okay? So I am perfectly okay with you using the calculator to do this because that's literally what you'd be doing if you were doing it by hand. So I don't care. Yes, you can do this on the test. Please show me what it is that you're doing so that I can follow along and go, oh yeah, I know what he's doing or she is doing. Okay? And so the answer is approximately 16. Remember, it is the exact same thing. We're talking about how many little boxes do you see in here? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, Yeah, I'd buy it. There's probably 16 in there. There's a lot of partial ones. Okay, that's pretty close. I think we can live with that. Okay. And again, it's just a matter of monkeying around with them to see if you come up with something interesting there. As far as eyeballing it, I mean. So x equals ln of y. Oh, nice. By the way, what does that look like? X equals ln of y is really another name for y equals e to the x, yes? They're identical. So don't freak out when you see that guy. Not a problem. And let's do e to the y. Let's do x equals e to the y plus 2. No, not plus 2. Let's back the train up. Not plus 2 there, I mean. Plus 2 out here. I gotta think what I want to do. I want to do minus 3 in here. Oh, that's more better. Cool. Excuse me. So I'd like to find the area between those curves. Between 1 and 5. Let's do between 1 and 4. Between 1 and 4. So my equations are this guy here. And this one here. I think that's right. That's correct. And I want to do between 1 and 4. Now when I write it like this, these are y values. Okay? So then the question is, who is more to the right? Right? Well, this guy is more to the right. So I'm going to do this one first minus the other one. Okay? dy, then I'm going to integrate from 1 to 4. Now you're like, ooh, well, how do I integrate that guy? Ugh, I didn't teach you that, did I? Well, that's frustrating. Oh, it's frustrating as heck. I'm sorry. I'm going to show you how to do it. I'm going to write the answer down. That's embarrassing. Why didn't I catch myself on that? That's embarrassing. I'm sorry. I should have seen that coming a mile away and caught myself. That's disturbing. I'm sorry. So anyway, that's how you would do it. We'll get into that a little bit more when we get into... Oh, wait. No, we haven't got there yet. I have to think about where I'm at in this class right now. No, we have not gotten there yet. So when we get there, you'll be like, oh, yeah, I know how to do this now. So, okay, good. Sorry. I should have thought about that when I made this problem. Oh, well. This is just free and bonus for you. Oh, cool. So the integral of ln of x is x ln x minus x. That's what it is. So, and this would have just been a substitution problem. And so that wouldn't have been terribly difficult. The only thing I messed up was just not showing you that minus. I'm just going to go ahead and distribute the negative through. Don't forget to distribute it there. That's that y equals 4. And 1. Oh, fiddle faddle. Fiddle faddle. Oh, sorry. And then I fell prey to it myself. These should have been absolute values here. That's embarrassing. That's embarrassing. One there too. There we go. It'll work now. The reason it didn't work out is because if you don't put an absolute value there, you're going to do 1 minus 3, and then you're going to have issues. Because that's negative, and we can't do negatives inside of an ln. That's a problem. Now, in theory, this one over here is also absolute value, but it doesn't matter in this case because we're putting in a 1, and ln of 1, and it just goes to 0, so it's fine. Yay! Alright, so I'm going to take this guy here minus this number here. Bam. About 1.84. If you come back over here and look between y equals 1 and y equals 4, I feel like we're a little short there. Put those in there and let's see what happens. Yep, I feel like we're a little short. I feel like that's a lot more than that. So let me pause where I figure out my mistake here. Alright, so first of all, it would help if I read the problem correctly. So those of you that are yelling at the TV and saying, Jay, you screwed up, you're right, I did. My bad. Let me get a new page. That's disturbing. What an idiot. Alright, so it's e to the y minus 3. There you go. Attaboy. Maybe you can do it. There you go. Sure. From 1 to 4. I bet it'll work this time. Bet if you actually do the right problem, it might work, Jay. So, this will just be e to the y minus 3 plus 2y minus, and then this will actually be y ln of y minus y, which will be negative and positive when we distribute. I bet it works. That's embarrassing. Just freaking embarrassing. Alright, so no, you want this, y minus 3, there you go, plus 2y minus y times the ln of y plus y such that y equals 4. Oops, don't forget your equals sign. What just happened there? Wait, it didn't get to such that. Such that y equals 4. And such that y equals 1. So if you take this number up here minus this number here, you get 6.03. If you look at that, I think I can convince myself that there's 6 boxes in there. There's 1, 2, 3, 4, 5 and a half, 6. Yeah, I'd buy that. That sounds about right. Sure. So again, that's, you cannot, I don't think you can underestimate how important it is, okay, to be able to look at a graph and see if you're right or wrong. And that's all it takes. I mean, we're just counting boxes. Well, it's finding areas, so yeah. So it's kind of a neat deal, I think. I think it really helps a person out to be able to do that. And I think it'll help you and save you a lot of time and messing around as well. Let's say you had y equals, I don't want to make one that's too terribly difficult. I'm going to do that guy. And I'm going to do x equals y squared, because I can. And if I graph those, what I end up with is this, and this, and this, and this. Yes? Where this is x equals y squared, and where this is y equals x squared. Now how in the devil are you going to do this? Well, very carefully. You can do it one of two ways, but you cannot do a half and half hodgepodge here. Okay? They intersect at the point 1, 1 and the point 0, 0, obviously. Okay? But you can't half fanny it here. Either you go with y equals x squared, which we currently have, and this guy will transform to y is the square root of x, well, technically plus or minus. Notice I only want the upper half, so the positive version. If I were doing it this way, I would go, alright, the top function is square root of x minus x squared, and I'm going from x equals 0 to x equals 1. Let's see if this works. So this should be x to the 1 half, so it's going to be x to the 3 halves times 2/3 minus x to the 3rd over 3 from 0 to 1. Put a 1 and you get 2/3 minus 1/3 is 1/3. In theory, that should be my answer. Now, you're like, could I do it the other way? Yes, you sure can. And so if you did, you'd have x is y squared. Well, what does that mean the other one's going to be? That means the other one's going to be x is the square root of y. Again, plus or minus. And so plus, obviously, because over here the x's are positive, so I need the positive square root of y. And so then here's the question. Well, this is y squared here. This is square root of y over here. So it's in essence the same problem this time. And in this case, again, it really doesn't matter. But remember, the y's have to go from 0 to 1. Those are my y values. Again, the answer will be the same. Now, they won't always look quite like that. So I want to do one that's similar to this, but different, so that you can see that. But we will get the same answer regardless. I'm going to pick one that's, I'm just going to draw a graph of one real quick. Again, very similar, because I don't want to, like, you know, this is not an algebra class where you're going to spend an hour solving some of these goofy things. Yeah, not going to happen. And, so again, I'll try to stay with some fairly straightforward ones. Yeah, I like this one here. Yeah, so let's, now, do I like that one? No, let's shift him over a ways. Let's do that. Let's do parentheses. No, no, no. Minus, you clown, plus 3. What? Oh. Parentheses. There we go. Yes! So I want to find that region in there, and I would be shocked if it wasn't also 1/3. But notice that the values are -3 to 0, or -3, 0, and -2 and 1. You see that? So if I were to do the same thing I just did a minute ago on this page, I would have x equals y squared minus 3, and I would have y is equal to x minus 3 squared. Let's double check that I wrote that right, because I'm really getting tired of messing this up. Y squared minus 3, x plus 3 squared. Attaboy. Now let's look at the points again. They were -3, 0 and -2, 1. Nope. -3, 0 and -2, 1. And that is where those guys cross one another. Okay. So now what we need to do is this. We need to decide, do we want to go side to side or up and down? Okay, and in this case, it really doesn't matter. The only time it would matter, as far as I'm concerned, is if I was given both of them as y equals functions. I'm going top to bottom right now. If I'm giving them both as x equals function, I'm going right and left right now. If one of them is easier to solve for than another, okay, in other words, if one of them was, I don't know, let's see, I dare you to solve this. 3x squared minus 2x ln of x. Go ahead, I dare you to get to x equals here in this guy. I dare you. Go ahead. I'll wait. No, I'm not going to wait. That's ridiculous. You cannot solve for x here. It's not possible. It's physically impossible to solve for that. So in this case, I would make the other equation also be a y equals function. But in the case of the one I just gave you, okay, then it's really straightforward, because I could make either one of them x equals or y equals functions. It makes really not a whole lot of difference to me one way or the other. I think I'm going to do this one. I'm going to make it a y equals. So it's going to be y squared is x plus 3. So then y is equal to plus or minus the square root of x plus 3. Now remember, the picture looks like this and like this and like this and like this. Yes? And yeah, so yes. If you don't know which one it is that you just graphed, the easy way to solve it is to go square root. No, that's not square root, Jay. Square root. No, try again. Square root of x plus 3. Oh, there it is. You see it, friend? Right there. Now, so it's the red minus the black. You see that? So it's going to be square root of x plus 3 minus x plus 3 squared dx. And from the x's, we're going from -3 to -2. So let's do this. So this is a substitution problem. In each case, we're going u is x plus 3 and du is dx. So it's not like it's a really hard problem here. This is just u to the 1/2. So u to the half right now. So it's going to be u to the 3/2 times 2/3. And I'm going to just kind of do that step in my head. To the 3/2 minus, this also is u, so u squared will be u cubed over 3 from -3 to -2. I don't think this one's very hard to do because you put a -2 in there, you're going to get -1 cubed. Negative, sorry, I don't do math good. -2 plus 3 is 1. To the 3/2 is 1. 2 times 2/3 is 2/3. On the lower end, excuse me, if you put -2 in there, you're going to get 1. Cubed is 1, minus 1/3 is 1/3. Put -3s in there, you're going to get zeros, you're going to get 1/3 again. And isn't that pretty? Okay? Now, that's all fine and dandy, but what if I had chosen to go the other route? What if I had chosen to have left it as x equals y squared minus 3, and the other one, which was y equals x minus 3 squared? Suppose I had chosen to do this differently, and I chose to solve for x here. Let it have the square root of y plus or minus, right? Plus or minus, and then plus 3. Okay? And again, if you don't know which one it is, and nobody would blame you for not knowing that, then come back in here and make yourself a new one and say x equals square root of y, and then is it minus 3? Did I do it right? Did I do minus 3? Oops, plus 3. Wait, what just happened? Oh! I wrote the problem wrong, didn't I? Yeah, because it was supposed to be x plus 3. There we go. And so as you can see, it's the positive version of this again. Okay? So the integral would be, again, come back over here and look at it. If we're going from right to left, it's going to be blue minus purple. So blue is that square root function minus the purple function, which is this one. Notice it's minus the entire thing. Don't mess that up. And then look what your y's are doing. Look where they intersect. They're intersecting here and here. The y's are going from 0 to 1. So the y's are going from 0 to 1, which in theory you'd think might give us a different answer. But remember, we're finding the exact same area. It has to work out the same. So when I do this, let's distribute this through there, that negative. This will become positive there. Okay. Yeah. Cool. Let's do this thing. And so then this is y to the 1/2. That's going to be y to the 3/2 times 2/3. That's plus 6y minus y cubed over 3. Oops, y cubed over 3 from 0 to 1. You run a 1 through there, you're going to get 2/3. You're going to get a mess here. What happened? This should have canceled out. Let's see where I messed that up. Oh, that's where I messed it up because I wrote it down wrong right here. This should have been a minus, right? That's what we said. Is that what we said over here? Yes, good for us. This should have been a negative, which then would have canceled this out because these guys would have canceled. There we go. 2/3 minus 1/3 is 1/3 again. And again, that is how you do these things. Again, you gotta love a graph because a graph will save you so much time and headache when it comes to these. Always check yourself. Cannot stress to you enough about that. Alright, that should get you done for 6.1.